Welcome to the second episode of Beer, Chai, and the Future, everyone. We got an amazing episode for you here today. Mike, what do we have?
Well, today we are going to dive into talking about robots. And so we have four main things that we want to talk about today. The first is the difference between autonomy and robotics, because there is a difference. The second thing is the sensors that a lot of these robotics are using. The third is how do we build autonomy and how is that actually created, because that's very different than just robotics. And then the last thing is we're going to leave you all with a little bit of homework and take a look at the state of autonomy today in the industry.
Yes, sir. School's back, and we are going to talk about robots today. Let's dive into it. All right. We took this concept from the levels of autonomy that exist in the world of cars. There's a level 1 autonomy, which is basically the cars we have today, and level 5 is like you can go to sleep and the car will take care of driving you to wherever you want to go. I think when you talked about sensors, Mike, like the sensors that exist across these robots and the kind of algorithms they use, and you stack them together, we can get a similar structure of levels of different products in the market today for lawn mowing robots too, correct?
Yeah, absolutely. And so sensors are one of the things that differentiates the robots right now. But even before that, I think it's important to really define the fact that there's a difference between robots and autonomy. And what we're looking for is autonomous robots at the end of this journey. So robots are capable of doing things that humans can do just a lot faster. And robots can be things like welding arms. So that's a great example of robotics. The robot doesn't have to think. It knows to do the same operation over and over again in exactly the same spot. So that's an example of robotics. Where autonomy is you have a machine that is capable of decision making. And that's really the biggest difference. So the example using the welding robot, if two pieces come in and those pieces are not properly aligned, and the robot can look at that and say, you know what, I'm not going to weld this. This is not set up correctly. Then that is stepping towards autonomy, as opposed to the robot that just welds those two pieces together, whether they're lined up or not.
Yeah, pretty much. In the assembly line settings where the environment is so structured, things happen in a very deterministic manner. And so the robot would just go weld it or put the bolt in place to fix a component on the chassis or something when the car is being made. In like a lawn and a landscape setting, it's unstructured. There's too many variances.
Absolutely, and that's why we need all of these different sensors. The robotics right now, none of them have just one type of sensor on them. They're all using multiple different types of sensors so that they can understand this very complex and very drastically changing world around them. Absolutely. So some of those sensors include LiDAR, which is a little laser that fires out thousands of times per second and spins around to understand how far something is from something else. That's what LiDAR does very well. And LiDAR can work in the dark, so it doesn't need light to understand where objects are. You combine that with GPS and RTK technology for positioning, so that mower understands where it is based on other satellites. So it uses triangulation to really get down to a few inches of where that machine is. And then they also have other sensors like camera data. And this is where we start to get into more autonomous mowers rather than robotic mowers, because with the camera vision and then a brain on board, it can start to make decisions based on what it sees in the environment.
Yep, so cameras bring it closer to the way we sense the reality. And then in that video that the robot is perceiving, it starts to identify objects using that brain on board, like you say, This is basically a neural network running on a GPU being a graphics processing unit. Typically, we have used those processors if we have played games, but now, the same thing goes on to a robot to run this neural network to figure out what is it that the robot is seeing. Because, for a computer, it's just a bunch of pixels with values, but what is it that value represents? And that's what that neural network does.
Absolutely. And so when we talk about levels, if we go back to what a level 1 robot or autonomous mower looks like at this point, level 1 still requires guide wire. So these are your smaller Roomba mowers that require you to install a guideline around the perimeter of the property to keep it within that system. A level 2 system is what they call e-posts. So this is a technology that is similar to GPS, but you set up the towers on the property so that it can understand very quickly where it is in relationship to those towers. Now, this is a very expensive technology and something that is still being developed, so it requires a lot of updating of the software with this technology right now. But as we get into level 3, we start to meld the LiDAR with the camera vision like you were talking about.
Yeah, and so it's like the robot in the earlier levels was dependent on these support systems, crutches being installed on the property to sort of figure out what's the boundary of service that it needs to do. As you get to a point where you have LiDAR, then it becomes smarter with, figuring out, obstacles around it. And with LiDAR, you would also see bigger robots carrying a LiDAR on them. So these would be more commercial mowers, 48-inch, 60-inch mowers with LiDAR installed on them. And the advantage is they would be able to mow faster, mow bigger areas, because these mowers are your typical commercial mowers that have LiDARs installed on them. So they have bigger, longer range of operation. And so they can take care of this big open fields. And it's in that progression that you see a camera come onto a robot and operate on more complex environments, not only staying within those big open fields, also being able to take care of smaller turf areas in and around the building. So that's a level 4 system, the way we are looking at it. The key difference though between a level 3 and a level 4 system is the coming of path planning and decision making. Your level 3 systems would be like trace and replay. You put a robot into the field, you take it around the property, and Mike, you've tried a bunch of them. Better that you elaborate how you've seen those operate on site.
Sure. So, like you were saying, the next step up kind of from the guide wires and having things on site would be this step towards autonomy, and that is trace and replay. So you basically mow the field exactly how you want it, and then that mower is capable of reproducing that same result as many times as you want it to. You don't ever have to fully mow the field again. It stores that information, knows where it needs to go, knows the path. Now, the trace and replay still requires a lot of open area. It's possible to go around some objects here and there, but it is definitely not able to do that by itself. And the trace and replay model has a downfall of if you add a new feature into the middle of that field. Let's say you install a flower bed right in the middle of that field. That trace and replace system is not going to be able to compensate for that new addition, and you're going to have to go back and retrace and remow that field so that it understands what to do. And that's in comparison to the next level up, which is able to understand those obstacles and simply move around them because it understands the size, it understands what to do. And when we're talking about how is autonomy built, that's done through machine learning. So they feed thousands and millions of photos into the brain of this machine to say, this is a tree, this is a tree, this is a tree. And they show them trees in all state. Exactly. This is a dog sitting. This is a dog walking. This is a dog laying down. they show them pictures of all of these different situations so that the brain within the computer can recognize that when it sees it at a pixel level, and then can make decisions about what it needs to do. So it could decide, oh, it's too dangerous for me to do anything, I need to completely stop. Or, hey, this is a tree, I know it's not going to move, so I'm going to mow around it, but I'm going to mow around it at a safe distance just to be sure. So that is kind of how autonomy is built. And the more that we send these machines out into the field and the more that these cameras see, the better that this camera vision and decision making process is going to be, because we're just feeding it lots and lots and lots of images. So that's how things are being built out today. And then as we talk about the future with level 5, like where do we see this going? And honestly, within a short period of time, I would say within 5 years, the sensors on these machines are going to be able to automate some processes for our people. So be able to write proposals for account managers based on turf conditions or bare spots or potentially dangerous trees, in addition to also mapping out potential obstacles or dangers on site for the crew and the operations manager. So being able to tag those items onto a live map view is really impressive.
Yep, and I think the sensor suite on the robots will also get more advanced. So a robot carrying a radar sensor would be able to make sense of soil moisture, and that's an additional data point that you end up collecting. With more, there's a standard Moore's law operating, right? Compute power gets cheaper, more compact with time. So you will be able to have more intelligent systems on board that will be able to recognize more details. So if the camera resolution improves, it can spot finer details like the color of leaves, the health of trees, and so on. And because of a more powerful compute on board, it will be able to make sense of these more minute features. Now, currently, as the robots are deploying, it's like it needs supervision. If you put the robot on site, someone needs to watch what it's doing. And in a few years from now, the robot will be watching what the rest of the crew is doing in terms of trimming, blowing, edging, and so on. Keep them honest, keep them in check.
Absolutely. And that's the thing is right now, we rely on crew input to understand about sites, right? But in the future, we're going to be able to see videos of our sites and really reduce the amount of time that an account manager or operations manager needs to go out to a site, because we're going to be able to understand what is happening on that site through all of this sensor data that's being collected from these machines.
Yep. And to just briefly touch upon how autonomy works, I mean, you did mention it, Mike. I just want to elaborate on that point a bit. These robots carry a perception system that helps them make sense of the environment. The level 1, level 2 mowers would have very simple systems like little ultrasound sensors that just see how far a wall is. They would look at the guide wires, so simple perception. More advanced level 3, level 4 robots would have lidars, cameras, even radars. Once they perceive that environment, they localize where they are in that environment and they identify the objects around them. That's like the step 2, like perceive and localize. Step 3 is like construct the whole scene, make a sense of these objects and the robot being inside a property, being inside like a landscape surrounded by objects in the background. And as it moves through that landscape, it makes sense of what it's left behind and what it's going to see going forward. And based on that, it plans and decides like, where do I go next? So, as you said, if there's a tree that comes in front of it, how do you navigate it? If it has taken care of one polygon of turf on site, how does it navigate to the next polygon? And once that decision is taken, it instructs the actuators, the motors, and all the different parts it has to move around, take a left, take a right, move straight, control the speed of the blade, and so on. So all these control decisions are taken, and then, these machines do their job.
Absolutely. And so it's really important too, when we're talking about this decision-making process, to mention that it happens almost instantaneously, right?
Yeah.
That this information cannot be fed from a camera up through the internet to somewhere else for it to compute and send directions back, because that's way too slow. Even with the fastest internet out there, it's not fast enough. We need to make split-second decisions, and so this power really has to be built into the mower itself so that it can do all of this decision making very quickly. Now, we mentioned homework, and
Yes.
we're getting to that point. But we're going to make it easy on everybody, right? And it should be fun, because a lot of the questions are going to be, well, which mower is right for me? And quite honestly, the answer is very different for every company. And I think the best advice that we can give to everyone is go talk to these companies yourself and find out where they are and how that fits into your company. At Level Green, we are using a wide array of all of these types, and there are use cases for all of these types of mowers. We have a lot of different property types within our company. If your company has a more narrow focus, then maybe all of these are not beneficial to you. So we're going to throw these names up on the screen. Go check out all these companies. We'll put the links in the comment section below. Go check them out and let us know what you think, where they fall into these different levels, because it's going to change very quickly over time. And so we want you guys to do your own due diligence, your own research. We're here for help. If you have questions, throw them in the comments, but it's important to talk to these people, and they want to talk to you.
Yep.
They want you to know about their product. And even if you're not ready to jump into it today and you don't want to sign a contract, that's okay. At least be aware of what is happening in the space.
Absolutely. Look at the robot that fits the type of properties that you service, the kind of business goals that you have going forward, the budgets that you have to try these systems out. I mean, apart from doing a research, do make some time to try them out later on this year, because in a couple of years, thousands of them will be on the properties. Quite probably one of the competitors that you have in your area would have one of these systems deployed, and imagine what it's going to do to their production rates and the way they price their services in the market. So that thing is not too far away. It's probably 2 years away from now. So
absolutely.
Yeah, let's get ready.
That's right. And if for some reason you can't get one of these companies come out to demo just for you, go visit the industry conferences. Tech Conference, GIE, Elevate, all of them are going to feature these technologies because they're up and coming and very important in the industry.
Absolutely. And in the next video, we're gonna record Mike's experience of deploying one of these robots. So you can definitely look forward to that.
Absolutely.
Thank you so much for tuning in, folks. See you next time.
See you next time.